So today our topic is basically diffraction of light. What it is? Diffraction of light. Now, what is diffraction of light? The meaning you understand. After that, definition and other formula you can understand from your notebook, whatever is given class 1. Okay. Now see, here I am keeping one opaque object. What object I am keeping? One opaque object. One opaque object is there, and here we have screen. Here we have screen. Now light is coming from here. Light is coming from here. This is opaque object is there, and here one sharp edge is there also. In opaque object, this is edge, is sharp edge. This is the screen. Now light is coming from here. Light is coming from here. Now white light is coming. What light? White light. Now, or basically you can write basically it is light only coming. Light is coming. Light means white light basically it is. Now the thing what will happen here? Now this opaque object, you say me here in this region. If this region I will consider, this region should be which region? Tell. Shadow region or illumination region? This region whatever I have done. Opaque object is there, light is coming. So it should be shadow, because opaque object means you know which will not allow light to pass through them. So here what I will do, now here it should have shadow region. So that means this region should be what? Shadow region. But due to diffraction phenomena, light will bend from here. Light will bend from here and it will enter to the shadow region. It will enter to the illumination region. This is illumination region, and it will enter to the shadow region. It will enter to the shadow region. So that means in shadow region, what you are seeing? Light. In shadow region, it should be dark, but you will see light. Light means what light? Now you will see here in this region, you will see you are one bright coming, bright dark like that. So now here it is. This is your bright. Your bright. Then again you will feel your dark. Here dark. Then bright. Like that it will happen. This is bright. Okay, bright I did like this. This is a bright color. Actually in shadow region, will you see bright? No, right? Normally you won't see, because light travels in straight line. Whatever light is coming here, light will not pass through this. So here light should not go to the shadow region. But what is happening? Now due to bending of light ray from the sharp edge of the opaque object, light is going into the shadow region, and you are getting bright and dark. So how you are getting the alternative bright and dark, like interference you are getting here, like YDSC. Like YDSC experiment you are getting here also, this one. But this is not continuing. You are slowly that width of this dark and bright is reducing. Okay, slowly width of the black and white is reducing. So that one will try to understand. But here what you have on screen, what we saw some alternate in shadow region. In shadow region we observe some alternate dark and bright fringe. Dark and bright spot you can tell spot, dark and bright, or bright and dark, whatever you can tell. Okay, what you want to say? Bright and dark you want to tell? Bright and dark spot. In other word I'll write also. Okay, fringe. So that means what you understood now, in shadow region you will have alternate dark and bright. That like interference you will have something. Okay, so this one will try to understand now. Clear idea what I told? So the phenomenon in which light bends around the corner of an obstacle. This opaque object also called as what basically? Obstacle. Around corner it bends, then we will get basically what? This one. This is called here what? Diffraction of light. This is the phenomenon, this is the process. About this one is clear? Now you see here one bright is coming. This central, this is center. The center basically coming so much bright. The center bright. And nearby one dark is there. Then after that bright is there. Like this bright darks are there or not? So we need to understand from the center, this dark at how much distance? This bright is how much distance? And this dark, how much distance we need to find? Actually this dark is called minima. In physics word, what will tell this is? Intensity is minimum, light intensity minimum, that's a minima. Or basically you can tell also secondary minima. What you can tell here? Secondary minima. You can tell this one secondary minima. Next to it is coming bright, right? Now see here, already bright you got here in center. Then this bright what I'll tell? This bright I'll tell as what it is. I'll tell as secondary. What I'll tell it is? I'll tell it is secondary bright. Secondary bright other name also maximum. That intensity is maximum here. So secondary maximum. Did you understand or not? So first bright, center is bright, then is minima. Down also same thing. Down what is this one? It is your secondary minima. This is what? This bright is what? This is your secondary maxima. Secondary maxima. So now understood or not? So what regions are forming in diffraction? Is it clear? Okay, I'll discuss again also. Now all of you listen. Same thing we want to understand. How we want to understand? Now here we want to keep a slit, one hole actually it is. Now here you want to keep a screen. You want to keep a screen. Now this is your slit. This is your slit. Now this is called what basically? Now you are taking one single slit. So this is called basically single slit diffraction. What do you call? Single slit diffraction. Single slit diffraction. What do you call? Single slit diffraction. Now width of this slit you can take as A. How much you can take? A. And here lights will come. Lights will come. Now light is coming. Now whatever previously I discussed, the same thing I am discussing here or not? But here instead of obstacle, what you have? Now this one have this corner. From here light will deviate. Now from here light will deviate. Now here one midpoint you consider. From here also light will deviate. Are you getting or not getting? Now they will do interference. Now this will be your center. Now this one you can take as a center O, and here to here this point you write P, this here to here it is Y or X, whatever take. Now this will be here our center. This is the central bright. Central bright will come here. Central bright. Then we'll try to understand here what is the central bright, fast minima, central minima, everything. Okay. Center will be bright. Any doubt? No doubt. This picture also given or not given? So for diffraction, suppose they asked what is diffraction, you can explain the diffraction like this, whatever previously I explained. Along with that, if they asked a single slit diffraction, then also you can explain this one. If single slit diffraction they asked, then you can explain this one. This is the single slit diffraction. Yes or no? Clear? Sometimes to converge light ray, we keep one type of lens, that is called convex lens. Then we can keep that one also, no worries. But without lens also we can do it. So this picture is given here. This picture, diffraction picture. Now if intensity pattern I want to see, so how I want to see here, you see, if suppose the intensity pattern, this is central bright you keep. Okay. So intensity pattern I want to see, I'll see here like this one. The center will be big distance, then small. Center will be big distance, then small. Okay. Now this is your central bright. Now this distance is the center. Here to here distance, here to here distance I want to find. This is your fast minima. What I am telling this one? Fast minima. Why this is fast minima? Because after central bright you check here. After central bright immediately what came? Dark spot came. Dark spot. So that's why this is your fast minima. This is also your fast minima. This is also your fast minima. This is your center. Now this is your what? Secondary bright. Okay, first you can write this one. This one is what basically? Now fast secondary bright. Same thing down also. This is also what you call? Fast secondary bright. Actually, why secondary bright you are telling? Go on focus. Secondary bright. Secondary bright why I am telling? Because the first one central already went. And central is different than this. See, this region is very big. This region is small. So this is different than this. That's why this is called central bright or primary. That's why I am telling this one is central bright. Once central bright or primary is there, now other things will be secondary. Now this one what you call? You tell. This one what will call? This is here second minima. Here second minima is coming. Second minima. So this one is called what do you call? Secondary bright. Secondary. This is secondary bright. Fast secondary bright. Primary. This is also fast secondary bright. This is your minima. This is your second minima. Like this you should understand. Intensity pattern. This is called what basically? Intensity pattern in diffraction. Intensity distribution. What do you call? Intensity distribution. Any doubt is there here? No doubt, right? Did you understand clearly all these things? Now next thing is, first you start from minima. First you start from minima. So here I'll start from secondary minima, or normally I'll start what basically? Now nth minima I want to study, position of nth minima. Okay, so heading what I'll give here, position of nth secondary minima or nth minima. This one you need to study. Now all of you listen carefully. Now here, if a path difference I'll check. Path difference. So what is the path difference here? Now here path difference will be delta x, which will be a sin theta. Previously it was d sin theta, but here it is a sin theta. A is what? What is A? A is given here. What is A? Width of the slit. Now next listen. Delta x equal to n lambda, which is a sin theta. Now here, if I write a sin theta, if I write here sin theta only. Okay, you don't forget this. Here delta x will be n lambda, because here for minima delta x is n lambda. But YDAC for constructive interference, for bright fringe, delta x equal to n lambda. So this is the difference is there. Why n lambda also, that proof is there. But you forget the proof, has to take with n lambda. For minima it is n lambda. Remember, minima I am doing. Now here I can write sin theta that is equal to n lambda by a. Now if theta is small, sin theta is nearly equal to theta, which is nearly equal to tan theta. Now next, here I can write this is theta, that is your n lambda by a. I can tell this one as position of, what I can tell? Position of nth minima. Position of what? Nth minima. Which position this is? Now this is angle. Now this is also I tell angular position. Angular position of nth minima. Similarly, you can check this picture. This is I told y. Here slit width. Now this one I can take one distance. This distance what I can give? Capital D. What is capital D? Distance between slit and screen. Capital D is what? Distance between slit and screen. Now this angle I can take theta, then only path difference will become a sin theta. This is the theta actually. Now if a picture I'll see here, can you tell me what is tan theta? Y, perpendicular by base. So tan theta is y by d. Tan theta is what? Tan theta is equal to y by d. Now same thing can I put here? If tan theta is y by d, equal to y by d, and if theta is small, then theta I can write y by d equal to n lambda by a. Now this y I can write as what? N lambda d by a. Now this is what more? This is what might tell? Position of which position? This is the linear position. Y means linear position. Theta means angular position. So now I can tell this one linear position of nth minima. Now here suppose you want to find, okay, for n equal to 1, theta 1 how much? Lambda by a. Theta for n equal to 2, how much theta value? Theta 2 lambda by a. Similarly and so on. Similarly for n equal to 1, y1 how much tell? Lambda d by a. So difference between theta and y you are understanding. For theta there is no capital D. Theta does not depend on capital D. And y depends on capital D. Y is direct proportional to capital D. Now next thing, for n equal to 2, that is your y2. What it is? Y2. What is y2? 2 lambda d by a. Like this it will go. Now all of you listen. So what we got? Whatever we got here, this is angular position of first minima. This is what? This is the first minima. Angular position. Which position? Angular position. This is what to tell? Second minima, angular position. But this is what? A linear position of first minima. And all of you can remember one thing, linear position of first minima. This one angle, this is the angle value, lambda by a, distance by distance. It will have no unit, or a unit if there na radian unit, like that, angle unit, degree unit. But here what unit? Here meter, centimeter, millimeter, like that they can give. Mostly meter, not give. D will be in meter. A will be in millimeter, D is meter, A is millimeter, lambda will be nanometer. So whatever answer will come here y1, that will come in millimeter or centimeter like that. Some unit is there for linear position. Did you understand or not? But for angular position it will be degree. So this idea should be clear in your brain. In your question it is given suppose fourth minima. Fourth minima means what? N equal to how much? N equal to how much? First n equal to 1, 2, 3, 4. This is your first minima. This is your second minima. This is your third minima. This is your fourth minima. Fourth minima na you can n equal to 4 you can substitute. Are you getting my point? Tell me what is capital D? Slit and screen. What is A? Width of the slit. Width of the slit. So this is about minima width. Now suppose I'll tell now about central maxima. Suppose I'm talking about central maxima. What is central maxima? Now central maxima, first thing is we have to find first angular width. Let's check about angular width. So what is the angular width? Angular width is theta. 2 theta 1. 2 theta 1. So 2 times lambda by A. Why I told 2 theta 1? That one also I'll give explanation. Let's write about linear position also. Now linear width. Linear width I'll tell. Linear width that will be 2y1 or basically 2 lambda d by A. Why I am telling this one? Now everyone you see this picture. This is your central bright, right? This is your central bright, right? This is your central bright. This central bright. Central from origin to first minima. How much distance? Lambda by A. Because first minima position is lambda by A. We calculated here. First minima is lambda by A. Here you calculated. First minima position lambda by A. Similarly, below also we have na. Below also we have first minima. So this is also what? Lambda by A. Lambda by A. Lambda by A. What value? 2 lambda by A. So angular width of central bright is what coming? 2 lambda by A. Similarly, linear width what? Now 2 lambda d by A. Here to here distance also. This is actually angle. Lambda by A means like this angle you are seeing. This is theta na. This is theta is lambda by A. Like that you are watching. Okay. So you don't write that one. Don't do that picture. You keep like this knowledge. Okay. Similarly, central width over. After central width, you have what? Now secondary maximum. Okay. Secondary maximum. So what do you write here? Now write here nothing. Heading what given? Check. Position of nth secondary maximum. Now for secondary maximum, you have to start from path difference. You know path difference A sin theta. But for secondary maximum, I'll take this one as 2n plus 1 lambda by 2 A sin theta. I can take 2n minus 1. But what I have taken? 2n plus 1. Or I can write this one as n plus 1 by 2 lambda into A sin theta. It is written or not written? What written, ma? What written? This is written, right? N plus 2n plus 1 by 2. When 2n plus 1 by 2 I am taking, that time n should start from 0, 1, 2, 3 like that. Okay? Yes or no? But you don't start from 0 n. Because 0 start na, it is becoming what? Lambda by A, like that. Theta if I'll check na, 0 starts na, it is lambda by 2A, like that it is coming up. Lambda by 2A. You start from, the lambda by 2A will not come because you see here, 0 don't start. Example I'll give. Here you go to lambda by A. Okay, lambda by A. Now I am talking about first secondary maxima. This is here. So definitely this value is greater than lambda by A, right? Greater than lambda by A. Yes or no? So that's why lambda by 2A you don't do. Okay. So you start from what? You start from what? 1. You check what given in notes? 1. Start from 1. This will be your first secondary maxima. First secondary maxima. This will be your second secondary maxima. 3 will be what? Third secondary maxima. Third secondary maxima. This formula you take. Now here what I'll do, after getting sin theta, you know, for theta very small, sin theta will be theta, then it will be n plus 1 by 2 into lambda by A. See, n minus 1 by 2 I have given for Young's double slit experiment. There it is for dark fringe. For dark fringe I have given that one. Yesterday given or not? But this is for this one. Now here theta equal to n plus half lambda by A. Now here what I'll do, now here I can tell my n is running from 1, 2, 3, and this one I can tell theta n, and I can tell here as theta is small, I can tell what as theta is small, then sine theta nearly equal to theta, that is nearly equal to tan theta. Now this is your angular position. This is your angular position of nth secondary maxima. You don't worry about the secondary word. Don't worry. This is maxima, but secondary maxima. Why I am telling secondary maxima? Now because already primary maxima is central bright. That is the reason. So now similarly, if I want to find yn, you tell what is yn? N plus 1 by 2. What will do here? Lambda 1 d only will multiply. That's it. What will multiply? 1 capital D. Now this will become what? Tell. This will become linear position. Linear position of nth secondary nth position of secondary maximum, not secondary direct right. Secondary I am writing shortcut 2ndri maximum. You write that one a secondary, huh? Or in what you can write, no reason. Otherwise you will get confused, na? Write secondary what, why, remember. And if you can take n equal to 1, for n equal to 1, okay, your theta 1 will come how much? Theta 1 will come 3 lambda by a, and your y1 will come how much? 3 lambda d by a. Like that other things also you can calculate. Yes or no? 2 will be there, I think 3 by 2 will be there, 3 by 2. So 3 lambda would do by 2. Okay, yes or no? Similarly theta 2 calculate, theta 3 calculate, y1 calculate, y2 calculate, and question you check what is given here. Always remember, angular position does not depend on distance between the slit and the screen. It d is 1 meter, d is 2 meter, d is 3 meter, this does not depend, but this depends. Okay, so this is what your diffraction. This all formula like me you have to remember along with picture. Any question asked na, you can give answer. Okay, I hope you understand. Yes or no? So thank you all of you.